Assalamualaikum. My name is Siti Nurlina binti Nur Azmi. My matrix number is AE190030.
Assalamualaikum warahmatullahi wabarakatuh. Saya Nurul Ruzana binti Abdullah, pelajar tahun 2 dari Fakulti Kejuruteraan Elektronik dan Elektronik.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arifah Nukalisha binti Khalid. My matric number is AE190057.
Assalamualaikum. Nama Syatira binti Harun, nombor matrik AE190035. For the simulation part, the circuit for the simulation has been set up, starting from the solar panel connected with the potentiometer, next to the current sensor, and then Arduino Uno R3, and the last one is the liquid crystal display or LCD. Solar panel will absorb solar energy. The solar energy will then be transferred to become electricity. The electricity produced will be stored in a rechargeable battery. The LCD will act as the rechargeable battery. The amount of solar energy absorbed in simulation depends on the changes percentage in potentiometer. There will be a connection between solar panel and rechargeable battery. The connection are the two sensors, that is the voltage sensor and current sensor. The reason of using those sensors are to detect parameter, that is current and voltage. At the same time, we will get to know how much current and voltage produced from the solar energy and stored inside the rechargeable battery. Both sensors had been attached with the Arduino Uno R3. The reading of the current and the voltage will be processed by the Arduino and its coding to be shown on the LCD. This is the coding of the Arduino, starting from the ADC value, which are the analog read. The ADC turns the analog voltage into a digital value. The function that we use to obtain the value of an analog signal is analog read. This function converts the value of the voltage on an analog input pin and returns a digital value from 0 to 1024. Next, we assign the ADC voltage as the ADC value. The current value is the ADC voltage minus offset voltage over sensitivity, which is the internal resistance. Next, the load voltage. The load voltage will be the current value times with 12. And the last one, we display the power, that is the load voltage times current value times current value. The formula is same as the P equals to I squared R. For LCD, we assign the LCD to print the current value, the voltage value, and the power value to display on the LCD by using this coding. Now let's run the simulation to see how it works. So as we can see, the LCD will display the current value, voltage value, and the power value. For the current value, it displays 0.81 ampere. For the voltage is 9 volt and the power is 5 volt. So now I change the percentage of the potentiometer from 67%, the previous one, to 25%. So let's see what the LCD will display. The LCD displays the different value of current, which is 0.59. The previous one is 0.81 ampere. The voltage is 7 volt and the power is 2 watt. This shows that the amount of solar energy absorbed in simulation depends on the changes value in potentiometer. That's all for the methodology and the simulation part. Thank you. For the temperature, we assign the temperature as float temp, and this is the degree of the temperature. For the LCD, it's lcd.create_char. Next, we assign the temperature as temp equals to ADC value times 5.0 divided by 1024 times 100. For the display, the LCD we print temperature equals to the value of temp. Now let's run the simulation to see the value of temperature. The temperature is 253.91 degree. Now I changed the percentage of the potentiometer from 20% to 67%. The temperature showed 255.37 degree.
So next, I will present to you about the result and discussion. Figure 1 shows the value of current and voltage on LCD while it is being run. As you can see here, the current is 0.59 ammeter and the voltage is 7 volt. Next, figure 2 shows the value of power on LCD while it is being run. So the power is 2 watt. This is the coding for current. From this coding, we can see the formula used are same as Ohm's law, V equal to IR. So the sensitivity in the coding was the internal resistance. Next, for power, the coding was assigned as above. We can see that the formula given are same as P equal I square R. This is the manual calculation. The power we got is 2.4367 watt. Next, figure 3 shows the value of current and voltage on LCD while it is being run after the value of potentiometer change. The value of potentiometer has changed. So the current we got is 0.01 ammeter and the voltage is 9 volt. Next, figure 4 shows the value of power on LCD while it is being run after the value of potentiometer change. As the value of potentiometer change, the power we've got is 5 watt. This is the coding for power. As we can see, the formula given are same as P equal to I squared R. This is the manual calculation. The power we've got is 5.9049 watt. From the result, we can say that the change of potentiometer, which act as solar energy, affect the value of voltage and current. The calculation of voltage and current in simulation had been programmed through Arduino coding using the formula Ohm's law V equal to IR and power P equal to I squared R. The value obtained from manual and simulation calculation are the same. So next, I want to present about the comparison between the system in our project and the industrial system. The first comparison is parameter. In our project, we only use voltage and current, while the industrial system use voltage, current, temperature, and light intensity. Next is the component. We only use voltage sensor and current sensor, while the industrial system use light sensor, current sensor, temperature sensor, and voltage sensor. The input for our project and the industrial system is same, which is solar energy. Next is the purpose. We create this system for educational purpose. while the industrial system create the system for industrial purpose. Next, about the cost. Our project is low cost because the system is simple, while the industrial system is high cost because the system is advanced. Next, we use software Arduino and Proteus, while the industrial system use Arduino and other complex software. Lastly is the system applicability. The system is still beginning phase and new, while the industrial system is the system has been tested, verified and calibrated. Next, I want to present about advantage and disadvantage of using solar energy to produce electricity. So, the advantage is solar power is pollution free and it causes no greenhouse gases to be emitted after installation. Next, it is renewable clean power that is available every day of the year. Even cloudy day produce some power. Lastly, it uses battery to store extra power for use at night. Next, for the disadvantage, the first one is no solar power at night, so there is a need for a large battery bank. The second one is depending on geographical location, the size of the solar panel vary for the same power generation. Lastly, cloudy day do not produce as much energy as sunny day. That's all from us. Thank you for watching.